This is for Year 11 Methods. It comes out of Chapter 6. It's 6.9, question number 8. The parabolic shape of an arch can be modelled by the quadratic. Take the starting point of the curve to be 3 meters from the ground and the origin of the axis to be at the ground on the left-hand side of the arch. Okay, here's our parabolic arch. And this is to be 3 meters above the ground, and that our axis starts on the left hand side and that the ground is 0. So there's 0 and that's 3, and there's the parabolic arch. Therefore I don't know what the x value of that, but I know the y value will be 3 also. At the top of the arch, the gradient of the tangent is 0. So at the top of the arch, the gradient of the tangent is 0. Therefore, at the top of the arch, the gradient of the parabola is 0. And at this point occurs when x equals 3 and a height of 5. So I know that that's at 3 and that will be 3 and 5. Since it's a parabola, I then know that that will be 6, and that should be 6, and that's 0 and 3. Okay, find C. So, to do part A, and I need to find C, then one piece of information I know is that h of 0 equals 3. Therefore, 3 equals a times 0 squared plus b times 0 plus c. C equals 3. Part B. Find the derivative h dash of x. H dash of x will be the derivative of this, which will be 2ax plus b. Part C. Find the values of a and b. Well, I'm told that the derivative up here equals 0, therefore h dash of 3 equals 0, so 0 equals 2 times a times 3, 6a plus b, and I also know that h of 3 equals 5, because I'm told that when x equals 3 the height is 5. So 5 equals, and I'm going to put this into this expression. So 25a plus 5b plus c, which is 3. Therefore I know that minus 2 equals 25a plus 5b. I'm quickly going to do this by substitution. I know that b equals minus 6a, therefore 2 equals 25a plus 5 times minus 6a, 2 equals 25a minus 30a, 2 equals minus 5a, a equals minus 215. I'm happy that I got a negative answer for a, because a is the coordinate, the coefficient of the x squared term, and I know my parabola is upside down. And b should equal minus 6 times 2 on 5 minus 12 on 5. So they're my two answers for a and b. A equals minus 2/5, b equals minus 12/5. Apart from the vertical sides of the arch, what is the largest gradient of the arch? So, my arch looks like this. I know that that coordinate there is 0 and 3, and I know that coordinate there is 6 and 3. If the gradient here is 0, what is the largest gradient of the arch? Well, the gradient here will be positive, the gradient here will be steeper, the gradient here will be steeper. So the steepest, the arch is going to get steeper and steeper and steeper down here. So if I limit x towards 0 of the derivative, that should give me the gradient. I know the gradient doesn't exist there because it's not a smooth join and it's an endpoint. But if I was to put 0 into the derivative, I would get b, which is going to be minus 12 on 5. I think that now I can't get minus 12 on 5 because I've got a positive gradient. Let's go back over here. That was minus 2/5. That's minus 2/5. That answer for B is positive, which means that answer for B is positive. So I think in part D, apart from the vertical sides, the largest is approaching 12/5. Can't equal 12/5 though because the derivative won't exist at that point because it's a sharp join or it's an endpoint.